multiple transformations. So it makes sense that we apply multiple transformations on objects. We want to scale them, rotate them, move them to different locations. We want to do all sorts of different transformations on them. And we could imagine it like this. So we have this transformation C, which we apply on our vertices. Then we apply B to the result, and then we apply some A, another transformation on that result. Now when you're doing this, you have to remember that, well, first of all, matrix multiplication is non-commutative. This means that if we apply this C, B, and A onto this vertex V, then this is not the same as if we were to apply C, then A, and then B. So you cannot exchange the order of these matrices. Well, you can, but the result will be different. But it is associative. So if we have these three transformations that we want to apply, we could just multiply those together into a single matrix, just do matrix-matrix multiplications on the transformations. We get a single matrix, and we apply the single matrix on the vertex. And this single matrix would encode all of the A, B, and C in it. Now, coming back to this non-commutative part, here's an example about this. So we have this triangle now, and right here we are first doing rotation and then translation. So we have this rotation angle. So we're first doing this. Let's say we rotate it somehow, and let's say we translate it then somewhere. So we move it, maybe we move it left over here. But if we exchange the order of the translation and rotation, so let's say we first translate and then rotate, so like this, then it's in another location. So the transformation result is different depending on the order in which we do these rotations and translations. And you can even see the matrix here is changing. Or if you want to imagine it, like if you have an object and you rotate it first and then move it up, then it's gonna be in one location. But if you move it up first and then rotate the entire space, then it's gonna be in another location. So in different libraries, you actually assign the position or the translation, the rotation, and scale separately with different functions. For example, here are three functions that allow you to set these values in Three.js. And then usually, well, you have to read this from the different documentations, then these are transformed into matrices and then applied in some specific order. Sometimes you can even change the order. So is the translation applied first and then scale and then rotation, or which order is the most logical one that they have set as default in that particular library. Then once these transformations that you have assigned to the object are encoded as matrices, they're multiplied together into a single matrix. This single matrix is usually called the model matrix because it applies a transformation, well, all the transformations that are encoded into it on a single model. So we send this model of this 3D object, let's say a cube, or maybe a model of a table or a chair, into the GPU, all its geometry, all these coordinates of the vertices. Then we send this single matrix, and then the single matrix is multiplied or applied to the coordinates of that model. So it's the model's transformation. This table needs to be scaled to be this big, rotated in this direction, and then translated or positioned in these coordinates. What the GPU actually does there is it takes all the vertices of that object. So our table, all the vertices, maybe there are 100 vertices, maybe it's 10,000, maybe it's 100,000 or 1,000,000 vertices. It takes all of these vertices and then does matrix vector multiplication with our model matrix, or one matrix that encodes this model's transformation, and applies it on all of the vertices in parallel. So there are many of these arithmetic logic units that can parallelly apply the same matrix on all the vertices. So instead of like going through the vertices one at a time, they're spread out, and then this calculation is done parallelly on all of them. And this is how we get this really fast transformation. This is the job of this vertex shader. So one of the shaders, shader codes that we send along from the CPU side to the GPU. And in the vertex shader, there is this code that does this model matrix times the vertex coordinate. Now from this video, you should understand multiple transformations. So the order of the transformation matrices matter. If you do rotation first, then translation, and then scaling, it will be different than if you would do it in another order. Then these matrices, these transformation matrices, all the transformations we want to do with an object, they're multiplied together into a single matrix. That matrix is called the model matrix, and it encompasses all the transformations for one 3D object. And then the vertex shader code is responsible for multiplying all the vertices of that model with the model matrix in parallel, transforming the entire model.